Why the fire? Well, because these experiments all involve torching solutions and vaporizing them into gaseous atoms. So first I'm going to go over the instrument itself and the experimental setup, including the part where we light everything on fire, and then I'll go into why we would do this, and then we will finally write some critical notes about it. So here's our schematic, and I'm going to start by directing your attention over here, where we will have a fuel and an oxidant, and we will flow them in through these tubes and use them to start a flame. Whoops! Let's try that again. Okay, much better. At the same time that this fire is burning, our analyte solution is being sucked up through this tube known as a nebulizer tube, and then that solution makes its way into the fire. Instead of using the term suck up though, a more scientific term would be aspirate. Now the flame is ideally hot enough to vaporize our analyte solution into gaseous atoms. We would call that process atomization. So the solution is atomized in the flame, and then if we're doing an absorption-based experiment, we will shine in light using a device known as a hollow cathode lamp, which we'll define more clearly later. And this light should have a wavelength that is capable of being absorbed by whatever atoms we are interested in studying in our analyte. And again, we'll get more into the logic of the experiment later. Right now, we're just going through the instrumental setup. So this light will be shined through the solution, and some of it may be absorbed by those atoms, and some makes it out to the detector, and then things work like what we learned during UV vis absorbance experiments. We detect the transmitted light, and we can then determine the absorbance of that sample. Again, we will get into the details of why we would use this instrument later. For now, we're just focusing on the instrument workings itself. So I have a little bit more to show you. I know there's something wrong with me. Wish I could blame it on COVID, but I've been using that slide for the past couple of years. But what is going to be brand new today is I'm going to actually show you the instrument itself rather than just show you the schematic, because there are a couple of points I can make with the instrument that I can't really do with PowerPoint. And we might as well take advantage of this online format where the world is our lecture hall. So I'm not going to take you to the usual CHEM lab this time, no. We're going to Tokyo.
Well, I don't know what you thought was going to happen. Clearly, I'm not going to Tokyo right now. But we can go to a different room.
So I'm wearing goggles in this video because fires can be a thing. But here's our instrument. There's our schematic. Let's just go through the various parts, starting with our nebulizer tube.
Now, I have activated the instrument, and so we see this tube is inserted in water, and we can see that that water level is going down with time. And that's because the tube is aspirating and sucking up that water and sending it into the atomic spectrometer. Over here, we have 4 different hollow cathode lamps. The one that's currently activated, you can't really tell, but it says iron on it,
indicating that if iron were actually in the sample we're currently aspirating, some of that light should be absorbed and we should see a signal. Finally, here's the flame.
Okay, we can see it looks like a normal flame, some blue, some orange. Now watch what happens when I change the sample that we're currently aspirating. I'm going to put this tube into some lithium and water. We get a very different color, this very nice magenta. And we're going to get into what's happening here when we talk more about atomic emission spectroscopy. But for now, just remember it, I'm going to bring it back later.